Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. Video we will be learning exercise 3.3 from the chapter matrices. So in this exercise we will be learning transpose, symmetric and skew symmetric of a matrix. So now let's move on to the exercise sums. Question 1. Find the transpose of each of the following matrices. So I said you transpose means what? We will be changing the column to rows and rows to columns. So I said you one thing, always change only columns to rows, which will be very easy for us. Okay. So I am taking this as let A matrix is equal to 5, 1 by 2 and minus 1. Okay. So what will be A transpose? A transpose means I will be changing this column to rows. So 5, 1 by 2 minus 1. So that's it. Only this is the answer. Subdivision 2. 1 minus 1, 2, 3. I am taking this as matrix B. So B transpose will be, I will be changing my column to rows. No, so first I will take this column. So 1, 2. So next I will take this minus 1, 3. That's it. This is the transpose. So now I will move on to subdivision 3. I have this matrix. So let me name this as C. So what will be my C transpose? I will be changing this column to rows. So minus 1, root 3, 2, 5. Second column, second row. Third column will become third row. That's it, over. Question 1 is over. Question 2. If A matrix and B matrix are given, then verify that A plus B the whole transpose is equal to A transpose plus B transpose. So let this be part 1 and part 2. So I am splitting this into part 1 and part 2. First I will be doing part 1, then part 2. Solution. First I will be taking for A plus B. So my matrix A. So I've written matrix A and matrix B. So now I'm going to add these two. So now I'm going to take the transpose. Transpose means what? A plus B the whole transpose means. So I will be taking transpose over here, A dash or A power T. Both also say transpose only. So I will be changing this column to rows. My first column will become first row. Second column will become second row. My third column will become third row. So that's it. This is the answer for A plus B the whole transpose. Let this be equation 1. My second part of the question will be A dash plus B dash is equal to A plus B the whole transpose. No. So therefore A dash will be, I will be changing it. No. So it will be minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1. This is my A transpose. And my B transpose will be minus 4, 1, 1, 1, 2, 3, minus 5, 0, 1. So now I'm going to add A transpose plus B transpose. So I'm going to add these two. So minus 1 minus 4 is minus 5. So 5 plus 1 is 6. Minus 2 plus 1 is minus 1. 2 plus 1 is 3. 7 plus 2 is 9. 1 plus 3 is 4. 3 minus 5 is minus 2. 9 plus 0 is 9. 1 plus 1 is 2. So this will be my equation 2. So therefore just check this equation 1 and 2. See first one, minus 5, 6, 1, minus 5, 6, 1. The second line, 3, 9, 4, 3, 9, 4. Then the third line minus 2, 9, 2, minus 2, 9, 2. So therefore, I will say that equation 1 is equal to equation 2. LHS is equal to RHS. Hence verified. Subdivision 2, A minus B the whole transpose is equal to A transpose minus B transpose. So first I will be doing for A minus B the whole transpose. Okay. So A minus B the whole transpose is equal to the whole transpose, isn't it? So now I will be adding, since here it is minus, I will be changing the sign. So plus, minus, minus, minus. So my positive will become negative, negative will become positive. So here 0 transpose I have to take, no? So my columns will become rows. First column, first row. Second column, second row. Third column, third row. Let this be equation 1. So now I will move on to the second part of the question. I will be finding A transpose and B transpose. So A transpose. So my B transpose is equal to. So I will be subtracting these two. So A dash minus B dash is equal to. Now, since here it is negative, I will be changing the sign. So positive, positive, negative, 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 positive, negative. So now I can directly subtract 0. So therefore this is equation 2. Equation 1 is equal to equation 2. LHS is equal to RHS, hence verified. Question 3. If transpose A matrix and B matrix are given, then we have to verify that A plus B the whole transpose is equal to A transpose plus B transpose. You see here only A transpose is given. A is not given. We also know the property that A transpose the whole transpose is equal to A, no? We will be using that only to find my A. So now here we have only A, no? So A transpose the whole transpose is equal to A. So then A is equal to, I will change the column to row. So 1 minus 1 0 4 2 1. This is my matrix A. So now A plus B the whole transpose is equal. Directly I will start adding these two. So I will have. So now transpose. Now transpose means I have to change my column to row and row to column. So I will be changing each and every column to row. So 2 5 1 4 1 4. Let this be equation 1. So the second part of the question, A transpose plus B transpose. Now A transpose is already known. So B transpose is equal to minus 1 1 2 2 1 3. So this is B transpose. So A transpose plus B transpose is equal to. Since these two are addition, I will add directly. So therefore A transpose plus B transpose is equal to. This is equation 2. Equation 1 is equal to equation 2. Hence, this is verified. Division 2, A minus B the whole transpose is equal to A transpose minus B transpose. So here also we know that A transpose the whole transpose is equal to A, isn't it? So in the previous question we already found it. So we will be using that. So we will have A transpose the whole transpose is equal to A. Then the matrix A is equal to, A transpose is already given in the question. So I will be changing all the columns to rows. So 3, minus 1, 0, 4, 2, 1. So this is my matrix A. So now I will be finding for A minus B the whole transpose. The whole transpose, which is equal to, So now since this is subtraction, I will be changing the sign, that is positive to negative. Here it is negative, so positive, negative, positive, positive, negative, positive, negative. Here also it is positive, so negative. So now I can directly add those two matrices to the whole transpose. So here if we take transpose, my column will become row. So first column as first row, second column as second row, third column as third row. So this is my answer for A minus B the whole transpose. So this is equation 1. So now we already know A transpose. So now let's find B transpose. So B transpose is minus 1, 1, 2, 2, 1, 3. So this is my B transpose. So A transpose minus B transpose is equal to. So now I will be changing all the positive signs to negative signs. So plus, plus, minus, 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 minus. So now I will be adding these. So this is my equation 2. So therefore equation 1 is equal to equation 2, LHS is equal to RHS, hence verified. If A transpose and B matrix is given, we have to find A plus 2B the whole transpose. So here also A transpose only is given. So A is not directly given. So I will be finding A first. Then we will move on to the question. So A solution. A transpose the whole transpose is equal to A. It means so A is equal to, I will change this column to rows, that is 7 method. So minus 2, 1, 3, 2. First column to first row, second column to second row. So now I will be substituting A plus 2B the whole transpose is equal to. So next I will be multiplying this element inside for each and every element, which is equal to minus 2, minus 2, minus 4, 1, 3 plus 2 is 5, 2 plus 4 is 6, the whole transpose. So next step, I will be changing my column to row. Okay, so minus 4, 5, first column as first row, second column as second row. So this is the required matrix. Question 5. For the matrices A and B, verify that AB the whole transpose is equal to B transpose into A transpose, where matrix A and B are given. So now using this, we will be finding that A into B the whole transpose is equal to B transpose into A transpose. Okay. So now solution. So this will be first part for both the subdivisions, and this will be the second part we will be doing. So first let us take LHS. So A into B the whole transpose is equal to, what is our A? 1 minus 4, 3. Into what is our B? Minus 1, 2, 1. No, this is 2, 1. So the whole transpose. Let us keep this transpose aside. Now we have to write the order of the matrix. What is the order of the first matrix? It's 3 by 1. So here it is 1 by 3. So second matrix is 1 by 3. So we will be cancelling out 1 and 1. So the order of the matrix is 3 by 3. So now I will be multiplying. So here, since I will be taking only the rows, no, from the first matrix. So since I have only one element, that is only one column, I will be taking only this. And how many columns are here? 3 columns are here. I will be writing thrice. So 1, 1, 1, minus 4, minus 4, minus 4, 3, 3, 3. So now I will be multiplying with this. So first element with first column. Since I don't have second element, I'm just leaving it. So here 2, 1. So now directly I can write it down. 1. So my matrix will be minus 1, 2, 1, 4, minus 8, minus 4, minus 3, 6, 3. The transpose, no, we shouldn't forget this transpose. So what is a transpose over here? It is, I will be changing this column to row. Minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4, 3. So let this be my equation 1. My RHS, if I go to my RHS, B transpose into A transpose. No, so I have to find B transpose first. So I have 1. So this is the transpose of matrix B. So next I will be taking for A transpose. So now I will be multiplying B transpose into A transpose. So what was my B transpose? Minus 1 to 1 into, what was my A transpose? 1 minus 4, 3. So now what is this? Matrix order 3 by 1, and here it is 1 by 3. So this and this will get cancelled. So 3 by 3. So the final matrix will be 3 by 3. And first I will be taking only the rows from the first matrix. So I have only one column. So only one element is there. So minus 1. Minus 1. Minus 1. This is minus 1. Okay. So 2, 1, 1, 2, 1. Now I will be multiplying with this 1, minus 4, 3, 3, minus 4, 1, 1, minus 4, 3. So now what is my final matrix? Minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4, 3. This is my equation 2. Therefore, equation 1 is equal to equation 2. LHS is equal to RHS. Subdivision 2. Two matrices are given. We have to verify AB the whole transpose is equal to B transpose A transpose. No. So first let us take the LHS alone, that is left hand side. So there we have to find AB the whole transpose. No. So first what is my A? 0, 1, 2, and my B is 1, 5, 7, the whole transpose. So now this is of the order 3 by 1 and this is of the order 1 by 3. So 1 and 1 will get cancelled. So 3 by 3. So the final matrix will be of the order 3 by 3. So therefore I have only one column. So I have to write this itself thrice. Why? Because I have 3 columns over here. 0, 0, 0, 1, 1, 1, 2, 2, 2. So now I will be multiplying. So 1, 5, 7. Directly you can do when it is column and row matrix. So it's very easy. So 1, 1, 5, 5, 7, 7. What will be my answer? 0, 1, 2, 0, 5, 10, 0, 7, 14. So now I have to take transpose, no? So 0, 1, 2, 0, 5, 10, 0, 7, 14. So this is my required matrix. So this will be equation 1. So now I will move on to my RHS, that is right hand side. So there I have to find B transpose into A transpose. No. So first I will be finding my B transpose. What is my B transpose over here? So these are the two matrices that we got. So now we have to multiply, that is B transpose into A transpose is equal to 157,012. So this is of the order 3 by 1 and this is of the order 1 by 3. So cancelling out these three, so we will get 3 by 3 matrix. So now 111555777. So now I will be multiplying it. Since I already taught you, I'm just doing it very fast. If you have any doubt or if you want me to do it slowly, just mention it in the comment box. That's it. This is the required equation and this will be equation 2. If you check equation 1 and 2, they both will be equal. So LHS is equal to RHS, hence verified. Question 6. If matrix A is given, then verify that A transpose into A is equal to I. So this is one of the very easy question. So we may get for 2 marks these types of questions. So first, let us find A transpose, then we will start multiplying it. So, A is given, so A transpose will be, so now I will be changing this column to row. So, first column as first row minus sin alpha cos alpha. So, this is my A transpose. Now let's start multiplying A transpose into A. So now I will be multiplying it. Step we will be simplifying it. So in one of the question I just said, when you get such trigonometry sums, I said mostly trigonometry matrices will end up with 1 0 or 0 matrix or identity matrix, etc. in terms of 1 and 0 only. So we have to be very, very careful, and we also know it beforehand that it is going to be 1 and 0. In such a way we have to do, and here it is cos alpha into cos alpha is cos square alpha, minus into minus plus, sin alpha into sin alpha is sin square alpha. Cos alpha sin alpha minus cos alpha sin alpha. Since if I have same, it won't confuse me, so only I have written cos alpha sin alpha. So here it is sin alpha cos alpha minus, plus into minus is minus, sin alpha cos alpha. Next here it is sin alpha into sin alpha is sin square alpha plus cos square alpha. So now we know that cos square alpha plus sin square alpha is 1. Here these two are same subtraction, so 0. Here it's 0, 1. Sin square alpha plus cos square alpha is 1. So therefore, which is equal to identity matrix. Hence, division 2, if matrix A is given, then verify that A transpose into A is equal to identity matrix. So first A transpose is given. Now let's find A transpose solution. So A transpose is equal to, so now I will be finding A transpose into A, that is, now I will be multiplying it. So here sin into sin is sin square alpha plus cos square alpha. Next here it is sin alpha cos alpha minus cos alpha sin alpha. These two are same only, no? So 0 directly I will write. So here also cos alpha sin alpha minus, plus into minus is minus, cos alpha sin alpha, this is 0, and here it is cos square alpha plus sin square alpha, which is equal to 1. Sin square x plus cos square x is 1. No? So 1, 0, 0 and here also 1, which is equal to I. Hence verified. Question 7, subdivision 1. Show that the matrix A is a symmetric matrix. So here we are asking us to prove that matrix A is symmetric. What is the condition for symmetric matrix? A transpose should be equal to A. No. So only this is the condition. So now let's start finding A transpose. So in A transpose, all my columns will become rows. No. So my first column as first row, second column as second row, third column as third row. So 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. So this is my A transpose. So if we check each and every corresponding elements, see here 1, 1, minus 1, minus 1, 5, 5, minus 1, minus 1, 2, 2, 1, 1, 5, 5, 1, 1, 3, 3. So therefore A is equal to A transpose, which is equal to A. Hence, Hence, A is a symmetric matrix. Hence, proved. Subdivision 2. Show that the matrix A is a skew symmetric matrix. So, we have to prove here also that A matrix is a skew symmetric matrix. What is the condition for skew symmetric matrix? A transpose should be equal to minus of the matrix A. So, now let's find A transpose. So my first column to first row, second column to second row, third column to third row. 0, minus 1, 1, 1, 0, minus 1, minus 1, 1, 0. So this is my A transpose. So now if I check here, see 0, 0, 1, minus 1, minus 1, plus 1, minus 1, plus 1, 0, 0, plus 1, minus 1, minus 1, minus 1, plus 1, plus 1, minus 1, 0. Sorry, this should be 0. 0. So now wherever I have negative, I have positive. Wherever I have positive, I have negative. No. So therefore, I will just take my negative sign out of the matrix. So if I take negative sign out, 0, negative will become positive. Positive will become negative. Negative, positive, positive, negative. So if you check here, now you check 0, 0, 1, 1, minus 1, minus 1, minus 1, minus 1, 0, 0, 1, 1, 1, 1, minus 1, minus 1, 0, 0. So therefore, see, minus sign alone, I took it out. So therefore, I will have A transpose is equal to minus of A. This is matrix A, no? So only A transpose is equal to minus A. Hence, A is skew symmetric. Hence proved. 8. For the matrix A, verify that A plus A transpose is a symmetric matrix. A minus A transpose is a skew symmetric matrix. So now let's check. For the first subdivision, let me check first. So here, till the last question, only one matrix was given, and that is A matrix, and we will find A transpose and we will check whether it is symmetric matrix or skew symmetric matrix. But a slight change in this question is that we have to take the sum of matrix A and transpose of it, and also we have to take that transpose, that is A plus A transpose, the whole transpose we have to take, and now we have to check whether it is symmetric matrix. And in the next subdivision they have given A minus A transpose. Now this is skew symmetric matrix. It means we will be finding A minus A transpose and also A minus A transpose, the whole transpose. So that will be skew symmetric matrix. That only they are asking us to check. So now let's start checking it. So matrix A is given. We don't know matrix A transpose, no. So let's start finding. So A transpose is equal to my first column as first row, second column as second row. So this is my transpose. So A plus A transpose is equal to, so I have written both also. Now I will be adding these two. 1 plus 1, 2, 5 plus 6, 11, 6 plus 5, 11, 7 plus 7, 14. Okay, so now I will be let this be equation 1. I will be finding the transpose of A plus A transpose, the whole transpose. So I will be taking the transpose of this. So 2, 11, 11, 14. So this will be equation 2. So my equation 1 is equal to equation 2. So therefore it is proved that A plus A transpose is equal to A transpose, A plus A transpose. A plus A transpose, the whole transpose is equal to A plus A transpose. So therefore it is, hence A plus A transpose is symmetric. Hence verified. Oh, second subdivision. Now let's start finding it. So already we found what is A transpose. Now what was our A transpose there? 1657. So now we have A minus A transpose now. So what was our A? 1567 minus 1657. So this is our A transpose now. So now I will be changing my sign, plus minus 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 minus. 1 minus 1 0, 5 minus 6 minus 1, 6 minus 1 1, 0. So this will be equation 1. So now I will be taking transpose, whole transpose, okay. So whole transpose is equal to 0, 1 minus 1, 0. So when you check these two, wherever you have positive, you have negative. See, positive, negative, negative, positive. So if I take my negative alone out, 0, negative of 1, 1, 0. That's it. So here it will be minus A the whole dash. No. So therefore, A minus A dash is equal to negative of the whole dash is equal to negative of A minus A dash. That's it. Hence verified. Therefore, it is Skew symmetric. Question 9. Find half of A plus A dash and half of A minus A dash when matrix A is given. So now let us split this into two parts. Okay, so let this be first part and let this be second part. So now first we will be finding the first part and then the second part. Before starting those two, let us find A transpose, which is common in both also. So A is given, A transpose let us find. So A transpose is 0 minus A minus B, A 0 minus C, B, C 0. So this will be A transpose. So now I will start finding my first part, which is half of A plus A transpose. So therefore, half of, this is a zero matrix. This is a zero matrix. So now I will be finding for half of A minus A transpose. So since it is negative over here, I am changing it to positive, negative, positive, positive, negative, positive, negative, negative. So now I will be adding these two. So half of So therefore, finally I will get, if I multiply this inside, I will get 0 minus A minus B, A 0 C minus C. Okay, B C 0. So hence we have found these two. Question 10. Express the following matrices as the sum of symmetric and skew symmetric matrix. In the beginning, in the introduction part, I just gave you a gist of this. I just gave you the sum of symmetric matrix alone. I gave you. I didn't teach you in detail. So now I will teach you in detail, and let's start. Solution. So see, sum of symmetric and skew symmetric is nothing but, we will be taking symmetric as half of A plus A dash. Next, we will be taking skew symmetric as half of A minus A dash. That's it. Only this. If we know, then we can do it automatically. So now let's get started. So now let's check for symmetric first. So let always P only will be for symmetric. You can take any other variable, but standard variable for symmetric is P. So P is equal to half of, let this be A, matrix A. So A plus A dash. Okay, so P is equal to half of, what is my A? 3, 5, 1 minus 1 plus, what is my A transpose? 3, 1, 5 minus 1. So, P is equal to half of 6, 6, 6 minus 2. So, therefore, P is equal to 3, 3, 3 minus 1. So now, what is the condition for symmetric? P is equal, P dash is equal, that is P transpose is equal to P, isn't it? So now I'm going to take transpose of P. So if I take transpose also, this one will become my row. So 3, 3, and next this one will become my row. So which is equal to P, no? So therefore I will say that, therefore A is symmetric. Next, let's check for skew symmetric. So let that be Q, and half of A minus A transpose. So half of, what was my A? So since it is minus, I'm going to change the sign. So plus, minus, 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 plus. So half of 3 minus 3 is 0. 5 minus 1, 4. 1 minus 4, 0. So now I will be taking this inside. So 0, 2 minus 2, 0. So this is my matrix Q. So now let me take transpose. So Q transpose is equal to 0 minus 2 to 0. Isn't it? So if I take all the negative out, that is Q dash is equal to minus of 0 to minus 2, 0. Then Q transpose is equal to minus Q. Okay, so therefore this satisfies this Q symmetric condition. Therefore, A is Q symmetric. Skew symmetric. Hence, now they are asking us to express in terms sum of symmetric and skew symmetric. Now, so therefore we have to add P and Q. So what was my P? 3, 3, 3 minus 1 plus, what is my Q? 0, 2 minus 2, 0. Isn't it? So now I'm going to add these two. So 3, 0. 3 plus 2, 5. 3 minus 2 is 1 minus 1. So therefore, I got back my matrix A. So this is the way to express the matrix in terms of as the sum of symmetric and skew symmetric matrix. Subdivision 3. I have this matrix. So let me name this as matrix B. Fine. So now I have to express as a sum of symmetric and skew symmetric. Now, so let me do for symmetric first. So before that, I'm going to take B transpose. So my first column will be my first row, second column, second row, third column, third row. So 3 minus 2 minus 4, 3 minus 2 minus 5 minus 1, 1, 2. This is my B transpose. So now I will be taking P is equal to half of B plus B transpose. So half of what is my B? So now I will be adding these two matrices. So half of 3 plus 3, 6, 3 minus 2, 1, minus 1 minus 4, minus 5, minus 2 plus 3, 1, minus 4, minus 4, minus 5, minus 4, 4. So now I will be taking it inside, that is 1 by 2. So 3, 1 by 2 minus 5 by 2, 1 by 2 minus 2 minus 2 minus 5 by 2 minus 2, 2. So this is my P. So now I will be taking transpose for P. Okay, so P is equal to, so this will become my row, no? So 3, 1 by 2 minus 5 by 2, and this will become my second row, minus 2, and here minus 5 by 2, minus 2, 2. So if we check each and every element, it is same. So P transpose is equal to P. So let this be equation 1. Now let me check for skew symmetric. So Q is equal to 1 by 2 of B minus B dash. So Q is equal to half of 2. So now I will be subtracting these two. In order to subtract, what we have to do? We have to change the sign. So minus, plus, plus, minus, plus, 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 minus, minus. So this is 6. Okay. So now I will be multiplying 1 by 2 inside. So Q is equal to 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3, 0. So now I will be taking transpose. Q transpose is equal to 0 minus 5 by 2 minus 3 by 2, 5 by 2, 0 minus 3, 3 by 2, 3, 0. So now if I take Q and Q dash, if I take all the negative signs out, what will I get? 0, 5 by 2, 3 by 2. My positive will become negative, negative will become positive. So here 0, 3, minus 3 by 2, minus 3, 0. So this is my Q, no? So Q dash is equal to minus Q. This I got it. So therefore it is a skew symmetric matrix. So now what have they asked? I have to express in terms of as a sum of symmetric and skew symmetric. No. So I have to add P plus Q. So now I will be adding these two matrices. So I will have 3 half plus 5, 1 plus 5 divided by 2 is 6 by 2, which is 3 again. And here minus 5 by 2 plus 3 by 2, that is minus 2 by 2, which is minus 1. So 1 by 2 minus 5 by 2, which is 4 by 2, minus 4 by 2, so minus 2. 2, 1, minus 5 by 2, minus 3 by 2, which is minus 8 by 2, which is minus 4, minus 2, minus 3, minus 5, 2. So which is matrix B. So this is expressing in terms of the sum of symmetric and skew symmetric matrix. By this it is over. If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.